All right, well, we have a few people online, so I'm going to go ahead and get started. Hello, everyone, and welcome to our press briefing. Half a decade. Oh, sorry, this is the wrong script. Our press briefing on sea level rise is accelerating globally. I'm Liza Lester from the AGU Media Relations Office, and we're going to begin with our panelists giving some brief presentations. We have two folks in the room here today, Ali Rellinger and Daniel Gilford, and online with us, we have Chris Piecuch and Roger Creel. So we'll hear from them as well. The slides and additional materials from this briefing are going to be posted to the press bulletin, and we'll also have a link to the recording on AGU's YouTube channel. Drop a link to those in the chat. Please bear with us if there's any technical issues, or drop notes in the chat about that as well. And I'm going to go ahead and get started with Daniel.
Thanks. Hi, everyone. My name is Daniel Gilford. I'm a climate scientist at Climate Central, which is a nonprofit organization based out of Princeton, New Jersey, studying how climate change is happening all around the world and what that means for local communities. So we put information together, especially for the press, media, meteorologists, trying to show how climate is changing in areas so that you can tell better stories about that. Today, we're going to be talking about human-caused sea level rise. So we have been studying sea level rise at Climate Central for many years, and recently we've been doing climate attribution work, which is where we try to put a number on the extent to which human beings have affected the climate system. And in this particular case, we're looking at sea level rise. So since pre-industrial, we've been increasing the amount of greenhouse gases in the atmosphere by burning fossil fuels and other greenhouse gases that have been released that are warming the planet. And as the planet warms, two things sort of primarily happen. One is the oceans get warmer, and that changes the density of the oceans and causes sea levels to rise. The other thing is that ice starts to melt all around the planet. So we see mountain glaciers, the Antarctic ice sheet, and the Greenland ice sheet starting to melt in response to climate change. So those three things are happening. Those two things are happening, and as they do, sea level rise is starting to occur all around the world, and we're seeing very consistent rise of waters. That really matters because people live along coastlines, and they can be affected by these extreme water levels that rise and is coupled to the higher sea levels. The next slide. How much higher are these sea levels? We can look around the world and try to understand how these sea levels are changing using information from the Earth and climate system. Yes. So we're talking here about attributable sea level rise. The way that we study this is we use models and observations to ascertain what is the change in sea levels that we're observing right now in the real world. How would those sea levels have changed in a world without human-caused climate change? And what is their difference? So the difference in those two things is what we call attributable sea level. And so I'm going to talk to you a little bit about how we calculate this, but really we're interested in how this particular number, this attributable sea level rise, looks around the world. So next slide. To do this, we look at all the different contributors that I mentioned earlier. So ice sheets, the ocean, ocean dynamics, changes in land water storage, and we think about how human beings have been affecting these. So we can take data from each one of these sources and then combine it with our best understanding of the scientific literature of how these particular parts of the climate system are changing. Next slide. So what we do is we actually scan the literature. We've looked over a broad range of literature to understand how attributable these changes in each one of these components is. And when we combine all that information together, it gives us a good estimate of how sea levels are changing around the world. And that's what I'm going to show in the next slide. So this is what the total attributable sea level rise around the world at the tide gauge records looks like. It's a pretty smooth field, but you can see influences from ice sheets, sort of further away from the ice sheets, you see the biggest changes. But generally speaking, there's something like 4 to 8 inches of sea level rise that's pretty persistent around the world. It depends on where you are, and the particular contributors vary by location. Next slide. So this matters because what it means is we are seeing more flood events. So here I'm defining flood events as just the 2 sigma level, or the very high level of the daily highest tide from recent years. And we're seeing that these thresholds of flood levels are being tripped more commonly because the sea levels are going up. So if we take the sea level rise that we were looking at, that we're observing, and we say remove the amount of attributable sea level rise that we've estimated, and then recalculate how many times you trip those thresholds, we're seeing a huge change in the amount of times that we're seeing these flood events. Sometimes up to 150 events over the last 20 years. So these changes are also accelerating. We were seeing not that many exceedances, say in the 1970s, but in the recent 2 decades, we're seeing about a tripling of the number of exceedances due to human-caused climate change. So with that, I'll stop and pass it to the next speaker, and thank you so much.
All right, thank you, Daniel. Our next speaker is Chris Piecuch from Woods Hole Oceanographic Institution.
Hi, thanks, Liza, and hello to everyone. Sorry, I'm unable to be there in person. As Liza said, my name is Chris Piecuch. I'm at Woods Hole Oceanographic up in Massachusetts, where I am a sea level scientist. And today I want to tell you about a study I had published just this morning that reports that the rate of US coastal sea level rise has doubled over the past 125 years. Next slide, please. So the motivation for this study came from a report released and commissioned by the US Department of Energy last summer. It was a wide-ranging report, but one of the chapters targeted sea level change in the US. And I've quoted here one of the key conclusions from that study as it relates to sea level, which is that US tide gauge measurements, the data source we use to track historical sea level rise, US tide gauge measurements reveal no obvious acceleration beyond the historical average rate of sea level rise. In other words, things aren't getting worse. Okay, and I saw this and I didn't really believe it, so I decided to do my own study of this. Next slide, please. Now, the DOE report was based on looking at historical data from just 4 or 5 individual locations across the nation. And for some of the reasons that Daniel just mentioned, you can't really just look at a record here and a record there and expect to have representative results for the entire US. So what I did is I took records from all of the available long tidal gauge records in the US. So this slide is showing some pictures of different tidal gauge stations in the states of Massachusetts and Rhode Island, near where I am. And I compiled them all together to quantify how much sea level has risen and whether that rate is increasing. Next slide, please. Oops, we're missing a really important slide.
There we go.
There we go. So this is really the take-home result of the paper, namely that coastal sea level has accelerated in the US over the past century. So what I'm showing here is a result from the paper. Let me orient you to this graph here. So along the horizontal axis on the bottom, I have time going from left to right, starting in the year 1900 and coming up to the present. And on the vertical axis to the left, I have what I'm calling RSL, relative sea level. So this is the amount of sea level change you measure from a point on land, as a tide gauge does. And this is the average sea level change over the contiguous United States over the past 125 years. That's what's shown year by year in the gray. This is my estimate of the change. It's about 40 centimeters, which translates to about 16 inches. Now that's about twice the rate of sea level rise that we saw on a global average that, say, was reported in the IPCC report released a couple of years ago. And just to put this in perspective, when we talk about 16 inches of sea level rise, I mean, y'all are sitting down there in Louisiana. 16 inches is comparable to the tidal range along the Gulf Coast. So you can kind of translate this as, what our grandparents saw as high tide, we're now seeing as the lowest tide of the day. So that's what this looks like in real terms. And to some extent, we've known this. What's really novel about, in other words, we've known that sea level has risen over the past century. What's novel about this study is that I'm arguing that the rate of that rise hasn't been constant. In other words, it's been ever increasing. So if you look again at this graph, what I've traced out with the orange line is essentially the curvature or bowing of that graph. In other words, as you go further into the future, there's more of an inclination of that graph to be inclined towards the vertical. That's telling us that the rate has increased. And in fact, it's doubled. The rate was about 2 millimeters a year back in the year 1900. Now it's 4. Okay, so we've seen a doubling of the rate of sea level rise in the US. And again, this is important. Again, 40% of the people in the US, almost 130 million people live in coastal counties. So this has direct bearing on how we live and work near the sea. Next slide, please. So just to summarize the main points, I used tidal gauge records, historical data from the US to quantify sea level acceleration. I found that rates doubled over the past century from about 2 to more than 4 millimeters per year in 2024. And importantly, that the recent rates that we're seeing now indeed exceed the historical average trend of 3 millimeters per year. If you'd like to reach out to me to talk more, I've given my contact info there. Thank you very much. I'll pass it on to the next person.
All right, thanks, Chris. Our next speaker is Roger Creel from Texas A&M University.
Hi, everyone. My name is Roger Creel. I'm from Texas A&M University, and I'm going to spend a few minutes talking about some research that we're presenting here, the title of which is Acceleration of Western Gulf Coast Sea Level Rise Influenced by River Discharge. So next slide, please. And the punchline of this research is that coastal sea level along the western Gulf Coast has accelerated in the 21st century, partly due to increased discharge from the Mississippi River. Next slide, please. And the motivation for this research this research was driven partly by a phenomenon that I think a lot of research has looked at recently, which is that sea level in the western Gulf rose faster over the last decade and a half than in the eastern Gulf. Next slide, please. And there have been a number of studies aimed at explaining why this happened. And there are a bunch of processes that we know do change sea level and that potentially could be contributing. That includes ice sheets melting. That includes oil and gas withdrawal. That includes regional ocean dynamics. Next slide, please. But it turns out that these processes put together aren't sufficient to capture the pattern that we see, which we're looking at here in the map and in the time series. Red means here faster or higher sea level trend from 2010 to 2022, and the lighter orange and yellow colors are showing us a slower sea level trend. Next slide, please. And it's important to understand why this regional pattern happens, because understanding these processes is key to helping improve projections of what the Gulf Coast line will look like over the next couple decades and century. Next slide, please. So what we find is that different processes are leading to the faster rise on different timescales. So on monthly timescales, we find that it's really wind and air pressure that are contributing most to driving sea level change. Next slide, please. But on annual to decadal timescales, which is the timescales that really drive policy, we find that river discharge is the important factor here. And to orient you to this plot, what we're looking at, time is moving from left to right, and in blue, the choppy line is annual sea level as shown as the difference between western Gulf Coast sea level and eastern. So that's that pattern that I was talking about. And then there's a smoother line passed through it. And then in salmon color, we're looking at what you get when you predict how much sea level change would be caused by a combination of Mississippi River discharge plus wind plus air pressure. Next slide, please. And one reason we might be seeing this pattern is that over in the 21st century, there's been more rainfall, at least in parts of the lower Mississippi River watershed. So on the left here, we're looking at the precipitation trend from 2010 to 2022. The big brown area is showing us that there's a drought in the western U.S., but in parts of the Mississippi River watershed, we're seeing green, we're seeing increased precipitation, and that trend on the right-hand side of the figure or of your screen is correlated then with the west minus east sea level difference to show us that there is some connection between precipitation and sea level change. So next slide, please. So to wrap up, there are implications for people of this research. We do need to understand why sea level rise is happening in order to project coastal flooding. And river discharge everywhere on Earth is an understudied driver of sea level, but particularly in the Gulf Coast, we think that it's important. And it's important on timescales specifically that are relevant for policymaking, the annual to decadal timescales. So if you want to talk more about this, I put my contact info below. Thank you all very much.
Thanks, Roger. And our last speaker is Ali Rellinger from Mississippi State University.
Hi, everyone. So I get to kind of wrap this up and change gears a little bit because I'm part of the Extension Service with Mississippi State and then the Mississippi Alabama Sea Grant. And my entire job is running a sea level rise resilience program where I am connecting people to sea level rise information and data. And so I'm going to talk a little bit about the different approaches and things that we're taking because you guys just saw a lot of really good information, but that's not enough for decision makers and people that are doing education and things alone, that they need more than just data to actually understand what is going on. So next slide. So what we've really learned is that learners need data, but it has to be packaged in a way that increases their understanding and provides context to them. So numbers alone don't mean a lot to your average K through 12 student or even a local decision maker, because we have to remember, being a scientist myself, that like a lot of people haven't taken science in a really long time, right? And so how do we help package this information in a way that increases understanding of it? So next slide. I'm going to show you 2 examples of how we have done this. And this is really leveraging a lot of social science research. So for example, we have great tools like the National Sea Level Explorer, which is an interagency tool of that shows sea level at the state level, local tide gauges, all of this stuff, but it's still fairly technical. And we know that people want access to local sea level rise data. I work here on the Gulf Coast and people want to know what's it doing where I am. But we also know that people tend to put off climate problems. They think that's not a problem for right now. And so one of the activities we've developed is our when does this happen activity. And you can see here, I have lots of fun pop culture events like when did the Super Nintendo get released, or when did Taylor Swift launch her first album? When did Hamilton hit Broadway? We play a lot of trivia with people because what we've learned from social science research is when you ground people's understanding of 10, 20, 30 years in the past, then you ask them to think about 10, 20, 30 years in the future, suddenly that seems much more relevant. And they think, wow, the world has really changed a lot in that time span. And then they start to contextualize that the world may change that much more going into the future. It also gives us a fun way to show data, like things like Chris talked about, the acceleration of it, and that we can put it on a graph in a way that is not quite as scary as just showing people a graph, and that they can see that the last 30 years is a lot less sea level than we're projecting in the next 30 years. So even if they don't understand the quadratic fits and things that we saw in the scientific literature, they can very clearly see that those steps are getting bigger and start to understand and ground that sense of, urgency, and that this isn't something to put off, and how quickly the world can change. If we can develop this much new technology, then the Earth can also change pretty fast in that same amount of time. Next slide. The other thing we know from social science research is that humans, not only are really bad at time perception, which I just talked about, we're also really bad at just understanding measurements. So we throw out these numbers. First of all, I put them in inches because we're in the United States, so millimeters mean nothing to folks here. So we start there, but still people misunderstand that too. They'll misestimate if you ask somebody, hey, how big's a foot? And you get people to do this. Well, they're going to give you all kinds of different amounts. And one of the most effective things to do is get out a ruler. but getting out a ruler is incredibly boring also. It's effective, but boring. So we try to come up with ways like, how can we get people to get out a ruler, but do something a little more engaging? And we solve that problem with friendship bracelets. Quite honestly, my house was filled with beads because I went to see Taylor Swift here in New Orleans. And I was like, what can we do with these beads? We could make friendship bracelets. And so now we can get people to measure out the amount of sea level that's expected to occur using that same data set and put it on a bracelet as a physical reminder. Or you can make a whole necklace and show year by year by year. So my one example here shows how the previous 30 years is not nearly as much sea level rise as we're projecting in the next 30 years. And we can physically show people how much that really is, so that when we go to talk about it, that they have a really good understanding that they're holding and touching to really contextualize that. So next slide. So really, we want to be able to take these complex data sets and make them more accessible to people, because people are interested in solutions to sea level rise, but they need to know how much is happening where they are. We don't want them underestimating it or overestimating it for decision-making purposes. And so these are strategies that allow us to share this data to people who might not really be interested in the little technical expertise, get them to understand it, and then have the actual locally relevant data so we can move forward doing decisions and things. So we're continuing to develop more of this work and see what other social science we can leverage to help fill in those blind spots for how we as humans actually use information that we get from science. That's it.
Well, thank you to our panelists for sharing that with us. We're going to jump to Q&A now. I think a lot of people in the room already know the spiel. Just raise your hand if you'd like to ask a question, and we'll call on you. If you're online, please put a note in the Q&A box. We can either open your mic, or if you want us to read your question, just put the whole question in there for us. Let's start with the room. Anyone?
Could I ask Chris, the DOE report that he mentioned, is there any reason that you could see someone would have picked the stations they picked and got the result? I guess what I'm asking is, like, there's always disagreement between scientists about different measurements and levels and what's happened. Like, is the DOE report something that we should put alongside it, or are you basically saying that that's not a legitimate finding in any way?
Yeah, well, I'll say three things. One is I can't speak to the motivations of the DOE authors for why they selected those particular sites. But I can certainly say things about those sites and give a general philosophical perspective. If I were to choose a handful of sites that would be most representative of the US behavior at large, I wouldn't have selected the sites they picked. Just to take two examples, since you all are down there on the Gulf Coast, 2 of the 4 locations they really emphasize are just south of you in Grand Isle, Louisiana, and also at Galveston, Texas. Why do I say those are not great sites to pick? Because they're really heavily influenced by processes that are happening very locally. As Roger said, sea level is a complicated thing. A lot of different factors on the earth can contribute to the seas rising or falling. In a place like southern Louisiana, yeah, you're impacted, by things like ocean dynamics, like Roger said. But more particularly, there's been a lot of literature on the influence of onshore oil and gas extraction from the subsurface. And when you extract fluids from the subsurface, you increase the tendency for the land itself to subside and compact. And that feels like sea level rise to someone at the coast. If you're on the coast, you don't care if the height of the sea rises or the land itself sinks. So the Grand Isle tide gauge is a gauge that's heavily influenced by vertical motion of the land. And the rate of that is not constant. In fact, peak onshore oil and gas production in the Louisiana area, it peaked around the 1960s and 1970s. So that's when you actually see, if you look at the data, that's when you see the fastest rates. Again, it's sort of a very large signal that swamps the more subtle climate change signal that's beneath it. A similar story at Galveston. It's not oil and gas production there. It's changing rates of groundwater withdrawal over time. That has a similar effect of causing the land to subside. So again, the point here is that both of those locations are subject to a lot of local effects, which, yes, there may not be an acceleration at a place like Grand Isle because of the effects that I've said. And that brings me to the second point, which is probably there isn't any one location in the US that's ideally suited for the whole. So one of the philosophical points I make in this paper is you get into a dangerous place if you're just choosing a couple of records and trying to extrapolate to the whole. I mean, we're kind of blessed in the US with a lot of data records, so why not use it all? So it's one of the main points I make in my paper, which is that, we've got all these nice long tidal gauge records from across the country. What happens when we put them all together and take an average? Okay, that way we are kind of smoothing out some of those local effects that I just mentioned to try to get at a larger scale aggregate sense. And when you do that, the data is very clear that you see a clear acceleration, like I showed. So again, I wouldn't have picked those individual gauges because they're not representative of the large scale, and I'd have to choose any small subset to try to make a statement of the whole. I'd try to take all the data we have, average it together, and to make that big aggregate statement.
Thanks.
Other questions in the room?
I've kind of a slightly technical question. I don't know if it's appropriate for this, about ocean fingerprinting, and the idea that southern hemisphere melt is going to enormously affect northeast coastal sea level rise. Is that a factor that you're thinking about, and to what extent are you thinking about sort of changes in modeling for like the glacial margin along the Antarctic?
You're specifically talking about the Antarctic ice sheet.
Yeah.
So historically, the Antarctic ice sheet has not melted very much. It's actually been pretty steady. There are some small changes, and it is very challenging to put attributability numbers on those changes because there's a lot of natural variability in the southern hemisphere, specifically over the Antarctic ice sheet. In our paper, we treat it as a big uncertainty, but because the numbers coming off the ice sheet in the last 100 years are actually relatively small, it doesn't play that big of a role in the changes that we're seeing in the figure that I showed. Sorry. But we expect going into the future, the Antarctic ice sheet will become a larger contributor, and that could lead and will lead to rises, particularly in the northern hemisphere, further away from the ice sheet, as we tend to see in our patterns. The pattern I was showing there, you see the huge influence of mountain glaciers in Greenland. The distances away from those places is where you're seeing the most sea level rise. And so we would expect as the Antarctic ice sheet, if the Antarctic ice sheet continues to melt a little bit and then starts to accelerate a lot, there's still some deep uncertainty in our understanding of ice sheet dynamics when it comes to the Antarctic ice sheet. But if it continues to melt, we would expect to see more of those impacts along the northeast coast.
We have a question online from Barbara Morin of WBUR. This is a question for Chris. Are tidal gauges the best way to estimate sea level rise, or are there other methods?
It's a great question. It depends. It depends on the time span that you're interested in and the time scale. So in the case of my study, I was interested in quantifying year-to-year changes over the past century. In that case, yes, tidal gauges are certainly the best, and I'd argue probably the only really robust source of those data. If you want to make statements that go much deeper back into the past, say before human beings started making measurements, you have to rely on things like natural archives. I can let Roger speak to that. I know he's had a lot more experience in that realm of change over geological timescales. But if you are concerned with more recent change, say over the past few decades, then you can avail yourself of satellite measurements. So since the early 1990s, we have had dedicated satellites orbiting Earth, radar technology that has given us a truly global picture of sea level change. That's in fact a much more complete picture than what you get with the tidal gauges. One of the disadvantages of the tide gauges is that they are only located at the coast and they're only in some parts of the coastline. So as I said, here in the US, we're fortunate to have a lot of records in places like Western Europe, Australia, but there are really big stretches of the global coastline, particularly in the global south, where we lack historical data. So that's where the satellite data become very, very important. But again, they only go back the past couple of decades. So again, depending on the time frame you're looking at, you may use these natural archives, which again, if Roger feels so compelled, he can describe a little bit more about the tidal gauges or satellite measurements.
Yeah, and going back earlier than tide gauges, we lean on geologic and or biological coastal features that have a defined relationship to sea level now, which allows us to infer what local sea level was in the past. So, for instance, salt marshes grow somewhere between highest astronomical tide and lowest astronomical tide. In the modern environment, you can go to a salt marsh and at some places along the US East Coast, salt marshes have been growing in fairly close to the same location for 5,000 years. So we can drill a core through that salt marsh and look at the communities of organisms living in the salt marsh and infer where sea level was in the past. And we can do this with other archives as well. Corals are very helpful for this purpose. In places that used to be weighed down by ice sheets and have since popped back up, we can go and look at beaches that used to be at near sea level but now have popped hundreds of feet in the air. So we use whatever we can, but all of those archives are less precise than tide gauges.
Maybe for all the panel, did any of the work that you're talking about today change future projections of sea level rise? And if so, how?
Yes, I'll say one thing, and then I'll actually tee up and kick it off to Daniel, because I think he's already started talking about it a bit when he started talking about the Antarctic ice sheets. But yes, I mean, the kind of data that I published or analyzed in my study that came out today is really, really crucial, say for vetting the climate models that we're using to make future projections. I mean, one of the nice developments that we've seen over the past couple of years is that studies that look at both the available historical records we have, say from tide gauges, and if they just extrapolate those forward, they're really, really similar to what you get with independent estimates from climate models. So by putting together a study like this and looking at the historical data and comparing it to what we get with the model-based projections, you build more confidence that different lines of evidence are converging towards the same answer.
Yeah, and I'll just add on top of that, sea level change is here right now. It's already affecting our coastlines. Places like downtown Charleston, South Carolina are seeing flooding events on a regular basis. Nuisance flooding is increasing. Many places across the country and across the world, we are seeing the effects of sea level right now going into so it's really helpful to anchor ourselves in the fact that we have seen sea level. That gives us a lot of sea level change. That gives a lot of confidence in our projections going forward that are consistent with those changes. These accelerations that Chris was talking about, that is something we probably will continue to see as we are, as the temperature of the climate continues to warm. Thinking about changes in sea level on the long scale, one big question that we have and we're continuing to try to understand is how the Antarctic ice sheet will respond to warming. There's some estimates that suggest there will be very big changes in the next century and some that are much more modest. So that is something that we're continuing to explore. But if we realize those large changes from the Antarctic ice sheet, we could see dramatic changes in sea level over the next 100 years.
And one other thing I would add is that I think one of the front lines of sea level science right now is zooming into local and regional scale to say there are processes that cause local and regional scale to differ substantially from even projections that we have right now. And so, for instance, there are places where vertical land motion projecting into the future may not be linear. Alaska is one of those places. As the whole permafrost coastline starts to thaw, it may start sinking dramatically. And river discharge, which was the focus of the work that I just talked about, is one of those processes that hasn't fully factored into projections of future change because that involves estimating how much river discharge will change in the future and then propagating that into sea level projections. And that's a step that we still need to work more on.
I think from a practitioner side too, it's helpful to note that, you know, the timescales of some of these things really are mattering to the people who are making planning and decisions. So we're talking about some of these processes that, you know, we know what's happening in the short term, like 10 to 30 years versus some of these longer term things, and knowing that a lot of the adaptation and resilience measures we're taking are only having a much shorter like planning horizon. So getting people to understand that time scale and what the variability is in what they're doing, and taking approaches like adaptation pathway planning where they can take stepwise increments to this, so they don't have to plan for some of the scenarios that are 100 years out, that we have intermediate things to do, and they can build you know, plans that then let them take the steps as we reach, you know, them. And that is a really important piece of understanding how much variability and things we have if it matches with the time scale of the things people are looking to do in response.
We have another question for Chris from Barbara Moran of WBUR. Did you send your results to anyone at DOE or spoken to anyone there about your study?
Yeah, great question. Yes. So a few things, as Barbara will probably know, because her colleagues at NPR reported on this a couple of months ago. So the climate working group that was commissioned to write the original report, which came out in July, that was disbanded in September. So it's unclear to me. So my understanding is that the original plan was that the group would put out a report, there'd be a 1-month public comment period, and then that group would respond to comment. So this disbanding of the climate working group came shortly after the closing of the public comment period. So it remains unclear to me whether there will be a response. I did email this morning all 5 authors of that report, providing them a link to the paper, and I did get a reply back from Judith Curry saying that she'd read it and she'd consider it in what she called the eventual revised chapter to the DOE report. So that suggests that they're going to consider it and that there may be a follow-on report.
I'd like to ask a last question of Allie, and that is, when people talk about these, like something like accelerating sea level rise,
Yeah.
how, in your experience, do people understand what that means? That an acceleration would double versus just like inches doubling?
Yeah, I think that can be really complicated, but some of these activities really do help them get to that understanding that a lot of times people ask, like, they want to know, they kind of think about it as like a step, like how much bigger is it going to get next year? And as we tell them that the step is getting bigger every year, and that really seems to hit home, and that they can see that those steps are now getting to like a critical threshold where like you really notice them in a way that we hadn't like necessarily in the past. And so they are noticing, and then on the ground in places where we do have tons of flooding, like Charleston was a good example around here, they are noticing that processes that they saw on that they know have always existed here are now happening more frequently, and they can connect those dots like, okay, this place is always flooded at some point, but now it's really consistent. And so, you know, once they are armed with that information, a lot of people can anecdotally put together that like, oh, that is where I see it. So, you know, getting them to understand they're not going to stand at the coast and just like watch the sea rise, and arm them with the, where would I see that in the community and how does that manifest itself? And then they can start to point out even more examples than I have even come up with in the community. So I think they can, people are, if you live on the coast, you are noticing it, especially in the Gulf.
Yeah. Last call for questions.
Can I ask one more about it? With climate change kind of increasingly politicized, how do you deal with that when you talk to people? Do you just avoid the climate change phrase, or?
I've pretty much always avoided the climate change phrase as the opening, and usually really grounded in asking people what they've seen, because I've lived on the Northern Gulf for 20 years, so I know how much I've seen flooding issues. And so you're hard pressed to find folks that haven't experienced flooding in some way, whether or not they want to attribute it to, climate change and things like that. So open the door with what have you seen? And then, hey, can I show you some things that explain it? Is generally pretty powerful, and it is impacting people. And so I think they are open to the conversation because it's just the reality. Like, people know they have to deal with it. So, we really try to start from that angle and let people, share experiences and see how we can then show them science that then supports their actual on the ground observations, and generally don't have much pushback at all. So, because like I said, unfortunately, we live in a place where it is flooding a lot. So it's hard to ignore the fact that it is flooding where I live.
And anecdotally, the people you speak to, do they think it's accelerating? Like, do they think it's worse now than 20, 30 years ago?
Yeah, I find a lot of buy-in anecdotally from people who do notice. Because like the example I said earlier, like they'll know that low spot that used to flood a lot, and they are noticing that it seems to flood a lot more than it used to. So I do think people are noticing, especially with the high tide, like flood events and things like that. That is where people see it in the community.
Well, there are no more questions. I want to thank our panelists. Thank you all for coming. And we'll have those recordings and slides and Chris's paper and AGU Advances available to you later today. And thank you for coming. Our next event at 2 is in-person only event with the Juno team from JPL. Thank you.
Thanks
Thanks, everyone.
Thanks, Chris and Roger.
Thank you.